Alright everybody, back with the part 3 of this video. I've already filmed some of it, so we're going to go back in time and catch you up. I've already done the unregulated 5-volt power section in the last video, and both of my boards are working as far as the game is concerned. But I do have an audio issue with this board, and couple of things we're going to test is, the audio section. I'm going to test these caps in the audio section. I might even test this cap over here for the 5 volts. There's really only 1, 2, 3, 4, 5 caps that need to be tested. You have this amplifier, this. But one of the things that I've done with my power setup using the centipede brick is you have 25 volts AC coming in to the board across these two diodes right here. And because the centipede brick puts out 36 volts, and it's not center tapped, or I guess it is center tapped, so I think if I grab one of these, it's around 18 volts, with ground being the other side. But I don't know what that waveform actually looks like, and I was going to cover maybe some, or try to understand myself a little bit better about full wave rectification versus half wave rectification. So right here, and I'll go into that hopefully in the video, but I'm not feeding both of these in there because it would be too much voltage if I fed both of these from the centipede brick. It would be like 36 volts. So I'm going to feed just one of these lines into one of these rectifiers, and it worked fine, and you guys will see that. And then that unregulated voltage, rectified voltage, goes to the audio amp, and then there's this 7812 that regulates it for the LM324. See if there's anything else I was going to cover. I think that's it. Going back in time, and then we'll be back. Real quick, back with I don't know if I showed this, but I did get a rheostat and wired it up to my speaker. Added that to my little test rig thing, which should come in handy and should work fine. It's 50 ohms, but if I hold let's see, if I hold test, should get the crowd background noise. And if I coin up, I did wire up my coin, and my volume does work. And I think this is the background noise. Yeah, so that's just the background noise for, you can hear a little scratching. So that's background noise volume, and then I can control it with the master volume as well. Now the only thing is I don't have, I need to wire up some select, because you're supposed to select a play, and then I guess it will, I don't have everything wired up, it'll be a lot easier, but I assume the good news is the amplifier is working. I think that background noise is going through the LM, I think 324, as well as that, whatever that amp is, so, but I'd have to check the whistles and press some buttons and stuff like that too. Cool. Alright, I think we're good here. Everything hooked up right, I think. Alright, 4.9 volts. That's good. Game's running. Turn down the contrast a little bit. Alright, so that's running, and let's see if we have some audio here. I do not have audio. Alright, so I'm going to have to look into that. I don't know. I might have a problem on this board on the 12 volt side. I'll have to double check that. We'll do that after this. But the board is running, and I do not have any audio at all. Let me see. Yeah, it's coined up. Don't hear it. Just checking voltage real quick on this 12-volt rail here. So this is 5 volts. See if you can see that. Should be a 5-volt capacitor right there. That's my regulated 12 volts, and we do have regulated 12 volts. And then I'm getting around 23 volts. That's my 18 volts unregulated, and I'm getting 23 volts. So either the amp, this capacitor here, I don't know if I mentioned it, this capacitor here is directly in line with the speaker, so it's not tied to a voltage rail. It's in line with the output going to the speaker. So I'm going to have to troubleshoot that audio section. Okay, so I'm back to the present, and this is the board that does not have audio, and I'm not exactly sure why. I wasn't filming it, but I was letting this board run, you know, right at the end where I just cut over, and this diode started smoking, or something was happening over here, and I tested it. I'm going to test the diode again here real quick, but it still seems to be working fine. So something happened. I saw a spark. Something happened. You know what I mean? I turned the game off, and now we got to troubleshoot it. I don't know exactly what's wrong. There's probably something wrong on this board. Also, I need to look at what kind of diodes these are and what they're rated for. Actually, let me do that real quick. All right, if you can see this is the unregulated 18 volt section. Again, it says it's fed by 25 volts AC coming across two 1N4001s, which is a rectifier diode, and these are rated. All the 1N40 series is rated for 1 amp. So part of my concern also is that, you know, if this circuit is pulling more than 1 amp, we're going to be stressing one of these diodes because I only have one connected. Part of me is thinking about jumpering these so that 1 volt VAC, one line of the voltage AC, is going across both rectifier diodes, just in my test setup. But I don't know if that's smart or not, so we'll hold off on that. But that's an idea I have. But we definitely need to be concerned if we're driving these, if it's pulling more than an amp on that circuit. And it very well could be, because each one of those lines is actually fused for 4 amps. I think it's these two red ones right there. Those are 4 amps, so maybe it's around close to an amp load, and so that's why they have 2. I don't know. All right, so the other thing is this, you know, and I'm not going to be able to explain this well, but I'm trying to understand it myself, so I figured I'd try to explain it, so at least my testing makes some sense. This is, you know, an AC waveform, obviously. And when you have half wave rectification, when you do basically full wave, it's going to basically just be this top part. So like after it goes through the diode, I expect to see only a waveform of this top part, like that. When you do a full wave, you basically also rectify, you know, the valleys or below 0 volts. And so it becomes like this. You know what I mean? So you're filling the gaps there when you do full wave rectification, right? But we're not doing that because that requires a bridge rectifier where you see like a diode, kind of like something like that. You know, I don't know. And power comes in. I'm not sure, but you get the idea. You've seen this format here. I'd have to go look it up exactly where the power comes in and to get the full wave rectification. But in this case, it's basically just 2 rectifier diodes. So we know it's full wave rectification. So we're losing this part down here, which basically means it's more inefficient, I think, is the bottom line. But I want to actually mess with this on my scope and just see if I can kind of determine, you know, what's going on there. And the other thing that I was concerned about is, or I was thinking is maybe, you know, here's our waveform of like this line, right? And I don't know if this would be the case or not. But then maybe the other waveform is like this. You know what I mean? Where it'd be compensating. And I don't know if that's the case or not. You see what I mean? Like where this is lining up with the valleys and stuff. I just have that kind of in the back of my mind as a concern. Obviously in the game this isn't going to matter. I'm just screwing around and trying to figure out if it's okay to power this board with just one of these taps off of the Centipede power brick versus using both, which the Atari football would. That's the whole thing. It's kind of a rat hole or rabbit hole discussion, but it's interesting to me, so I want to kind of screw around. Alright, the board is running, as you can see here, and hopefully you can see this okay. I have my scope on frequency measurement, and you can see there we're getting 60 hertz, and you can kind of see the AC waveform there. I am on ×10. Let me go to power measurement, and it is ×10. That's 18 volts AC on both of those lines. Now these are not connected to the board yet, as an example. Alright, I put away the scope for a second here. I just figured I'd do some temperature measurements because I was messing around with it. It's actually the next day. So we're getting 23 volts across this diode, and obviously these two sides are tied together, and I'm getting 23 volts there. So I'll come back to that AC thing in a bit. Obviously there's DC waveform. I have to switch it to DC, not AC. And then, but let's come to our 78. That's interesting. Okay, there we go. So this is our 7812, which is I think a 1 amp voltage regulator. We got 23 volts coming in, nothing going out. So this voltage regulator is bad. There's no voltage here. And when I think earlier in the video I did show me measuring this voltage, and I was getting voltage there. So something probably, either it just failed and it was a coincidence, but something caused that to fail. My cap is obviously okay, so maybe this LM324 is bad. I actually don't have any 7812s on hand. I might try to find one and pull one off a board, or maybe put in a 7815 if this LM324 can handle 15 volts. I don't know, we'll see. Just to test with as I order it. So let me get the schematic out and try to figure out what's going on there. Actually, real quick, I'll do I wanted to check. Alright, so I don't know if I'm doing this right. Haven't had the need to try to do this, but I'm going to try to measure both of these AC waveforms simultaneously. I have volts per division set to 10. I have a 10x probe. I have it set for both channel 1 and channel 2. I have them in chop mode and horizontal position. Let me just do A. Alright, which one's A? This one right here. Alright, so we can see, actually this is one of the AC lines. So you can see this, my A channel AC waveform, and then I'm going to touch the other one, and it's kind of what I was thinking, right? Like they're kind of, if I have my scope set up right, I kind of proved what I was kind of drawing, you know, before, where the other lug, gosh dang, I can't think right now. The other AC line coming from the transformer, the other winding, I guess, is basically different timing. I don't know. Maybe that's just how my scope has it set up. I don't know, but it kind of looks like it is, right? Like it's not ideal to not have both of these hooked up, probably. Yeah, I think I have it set up right in my theory. I just proved out my theory, I think. We'll see. You guys can comment. Alright, I did some investigation. So The maximum amps, I think, for volts for the 7812 is 30 volts input, and we got 23 volts unregulated coming from our AC line. We had that whether we were using one tap of the 36 volts AC, which was 18 volts AC, we get 23 volts, and I also wired up the other one, just jumpered it real quick, as you can see. So now I have 36 volts AC going to two different diodes, and it's still 23 volts DC. And I think that's because of the waveform, right? We're chopping off the top, and so we're just getting a more consistent voltage because they're alternating or something like that. Kind of like, yeah, basically, because we're using both AC lines, we're basically getting this, right? And it's chopping off, you know, the top of both of these waveforms and putting them together as one DC voltage. I don't know. I'm not describing it right, but I think we're better. We're better using both of these windings. So I'm actually going to wire that up permanently as well. The other thing is the LM324 can accept higher than 12 volts as well. I think it can go up to 30 volts. So I am going to try to put a 7815 in here just in the short term, just to see if we can get our amplifier working. So either this amp is bad, the LM234 is bad, or something, but we need to get voltage to the 324 first. Alright, crazy, I'm almost done with the video, but I'm coming back to fix some of this because I actually did some research, and going through that whole AC, it's probably basic for any electrical engineer or anybody that studied this at all, even in maybe high school, but I went into it backwards. I didn't really understand what was going on. This is basically half-wave rectification here, where, alright, I was interrupted, but anyway, you have a transformer, and it's basically, there's a single diode, so this is single diode half-wave rectification. You got two, you know, lugs coming off of a transformer. This is a primary side, secondary side, and the waveform, you know, goes over here, but obviously it's AC current, so the wave coming back the other way is getting blocked, so only the top part is being rectified, right? Not the bottom part, because it's being blocked, obviously. Something like that. But and this is what your waveform is, and when I was measuring DC voltage, we obviously have a capacitor here that is smoothing it out and storing the power, so it's probably, you know, you don't see it like kind of probably jumping around is what I assume. I don't know for sure. But then there's this concept of two diode full wave rectification. So the other option is to do a bridge rectifier with 4 diodes, and then you can rectify, you know, both sides of this wave. But in this case, the 2 diode full wave rectification, you actually need a center tap transformer, which is what the centipede transformer is. So there's basically one tap coming this way, there's the center tap, and then you have the other lug or other part of the winding of the secondary side. And so this way, you know, the one waveform, the top part is coming this way and getting rectified, not the bottom part. And then the load gets tied to the center tap, and you also have another wave that is just like we saw, right, which is the other side of it, which is kind of like out of, I don't know if it's called out of phase or not, but it is 180 degrees out of phase. So that's where you get the little up in between the valleys and stuff like that. So this is the circuit basically that I know this is a different board right now, but that's the circuit that Atari football is using. Is a 2 diode full wave rectification, and it took me a little bit of research to figure it out, but I kind of went into it backwards. But anyway, now we're all squared away, I think. Now back on to fixing the audio section. Alright, I hooked up my working board real quick. What we're going to look at here is, first off, this B, if you can see that, B7 pin 2, we're going to look at that when we first coin up, and then after we press the coin button, because that basically triggers this transistor that probably turns on the amplifier or something. I'm not sure, but it's got to be doing something. And we're also going to look at B7 pin 4, which is on the noise generation line. So let me power off. Power back on. This is the working board with working audio. We're going to look at B7 pin 4. And that is the noise, like the crowd noise, what the crowd noise circuit should look like. Get my scope away from that heat source. Freaking hot ass thing. I already burnt myself once on that damn thing. Alright, B7 pin 4 right there. Okay, so that's our noise generator, and there's pin 2. And I might need to hook onto that so I can show you. Let's see, can I? Yeah. I have, be right back. Okay, I have B7 pin 2, which is going to probably toggle after I power it up. We'll see what it's like when we power it up, and then we'll see what it's like when we coin up. So first let's power up. So it's around almost 4 volts, 3.7 volts. And then as soon as I coin up, our sound comes on. I believe it hits this transistor here or something, or that, I don't know, one of those transistors. One of these, this one or that one, I'm not sure which one. And then it grounds out basically. So now I'm going to hook on to my non-working board and compare it, see if we get the same behavior. Alright, this is the non-working audio board. Right there. I just turned it on. We're hooked up to B7 pin 2. We're going to coin up. Alright, so that's working correctly. Now let's check if we have our audio signal on pin 4. And we do. So the noise generator we know is working correctly. So the transistor here is working right. I think if we come to our whoops, you probably can't see, but I'm having a feeling that it's our audio amp that's messed up. Because if we come to, or it could be this, I guess. It has to come through here. D8 pin 6. Actually, that noise goes to all of this, is tied to the D8 on all of these pins, and then it goes to pin 6, 3, 11, and 8. I'll look at that real quick. Alright, I checked this out. This part of the circuit here, basically the noise from the crowd noise is coming up here to pin 2. Pin 1 is high, and that's probably an OR, so there's activity on R3, and then probably depending on what's happening in the game, it probably changes, like maybe the tone or something like that, because there's different resistance here. And then I checked the LM324s. I looked at the outputs. They all, look good. Let's see. I think that might be either pin 11 or pin 14. I'm not sure. And pin 1. Actually, I could do that real quick. I'll back up a little bit, I guess. Alright, what did I say? Pin of the audio amp. Of the LM324. We're looking at pin 1. That's pin 1 there. And then the other output, I think, is either 14 or 11. There's 14, 13, 12, 11. Yeah, I think it's 14 is the other output. So that looked good. So then I realized that I actually have an amplifier built in to my PVM right here, and I have that already pre-wired. So what I did is the input into the TDA 1004 amplifier is right here, and we have audio. but coming through this amplifier that's built into my TV. So I know that the sound is working, it's just this amplifier is bad. And I did that, just a quick little test there with my, I forgot I even had this. I actually need to probably make this into like a probe or something to make it a little bit easier to troubleshoot the audio stuff, but that's a quick and dirty that I did. So anyway, I think this is fine. I need to order a 7812 to 7815. I actually put a 7815 in there. I don't know if I did show that. Let me show that this is actually getting 15 volts. That's 23. Right there, 15 volts. It's off screen, but you can see 1.5. I'm on times 10. So it's outputting 15 volts, and that's fine for the LM324. I could probably leave it like that, but I'll put it in the original 7812. So I need to order some parts. TDA 1004, got to find out where to get those from. And I think we should be okay, even though I'm not testing the other sounds yet. Alright, so I did remove the amplifier. I cut off the legs and got it out pretty easily, but getting this heatsink off is not going to be easy. I'm just going to put a newer style heatsink on it, and hopefully it holds up. This is my other power supply where I mounted this other type of resistor on it, so let's power it up. Works. And we do have audio. Good. It actually sounds a little bit louder too than the other one. So that fixed our issue, our amplifier issue on there. I don't know how I'll work this into the video. Let's turn that down. But I think that's it for this video. Audio issue. No, I'll come back. I'll do a heat sink on that real quick and then come back. The thermal paste that I had, the thermal adhesive, was totally jacked up. I had to, let me see if I actually have, I had to like rip it apart even to get some that was usable, and it's not great. I'm not happy about that. But anyway, I think I'm done. I'm going to hit the test button here and underscan, so you can see that the ROM and RAM are okay. It says A, that's my settings. But that's it. Atari football fixed. Did some power. This is Futzin with football. The series is over. I got 2 working board sets. Hopefully this holds up and dissipates enough heat with that little cheap heat sink there. I doubt it. It's probably going to fail eventually, but I got plenty more if I need them. That's it, guys. Oh yeah, this is it. This is the picture of the thing. Is just, I don't know what happened. The air got to it, so I think the thermal paste looks like putty. All right. Cheers.